Hello, I'm Mehmet. I will make an introduction to you of our project, Smart Electric Hybrid Bike, focused on BMS. This is our project team. Usage of the electric bike is increasing day by day, but some technologies cannot catch it. If we look at the battery, they can easily explode if the monitoring mechanism is not enough. With the project, a lot battery management system will use to the modern bikes. This is three types of electric bikes on the market. And this is the selection criteria of e-bikes. Most of the customers look at the battery of the bike. With the BMS of the project, battery some parameters such as temperature and voltage will always monitor, and in case of the anomaly, it will interfere automatically. Motivation of the project is to provide a better battery management system and increasing the battery life. With the regenerative energy recovery, the battery's usage is in driving will also increase. This is the number of e-bikes in Europe. And this is our technical requirements. According to bicycle law, electric bikes must not reach above 25 km per hour. Bicycle motor must not exist. 250 watt power.
Design and calculations. 1. Motor. The motor structure used in electric bicycle is divided into two, hub motor and mid-drive motor. The structural differences of these engines can also be understood from the name. Mid-drive motors are usually connected to the wheel while the chain system on pedal is used. There is more space, but it is usually positioned just above the pedal. The biggest advantage of being connected to the chain system is that maximum efficiency and torque values can be achieved at more than a bicycle speed. Before the calculations, the motor limits are 25 km per hour speed and 250 watt motor power by complying with the bicycle laws and rule. If we consider the air and ground friction of a bicycle with a total weight of 90 kilograms, these forces consume approximately 80 watts of power. These are values that are valid on a completely straight path. If calculations are made in place like Davutpaşa campus where there is no straight road, the power required to climb a 5% slope with a constant speed of 25 km per hour is 388 watts. According to these values, even the 250 watt motor will not be enough. The maximum limit must be determined so that the motor can be connected to the chain and pedal system. For this reason, it has been stated above that 80 watts of energy is spent on friction in order to be able to move steadily. Equation 1 can be used to find the force applied to the bicycle from this value. When choosing a motor, the priority is to have a motor that supports high efficiency and regenerative energy. The cost is also quite important. In these conditions, brushed and brushless DC motors were seen as most suitable motors for this purpose. When market research was conducted, it was thought that the DC brushed motor with the code in this figure, which was suitable for these features, was the most suitable. The RPM of motor is equal to 300. There is the motor wheel gear ratio required to ensure that the maximum speed does not exceed 25 km per hour in the highest gear is given like this. Our calculation for chain selection is as seen here. It is sufficient for the motor be used in the bicycle to move in one direction. But since it should be used as regenerative energy conservation in the same direction, a two-quadrant driver should be prepared. When TV is off position, this is driving, and right one is regenerative braking mode. Engine specifications must be known in order to enter battery calculations. The power and voltage calculation to be made according to the motor selection is as follows: P is equals to I times V. It is known that the I times V value should be 250, and minimum value of 27 volt can be obtained by connecting 9 pieces of Li-ion battery, which is to the minimum of 3 volts. The selected motor will have a higher value than the 24 volt motor. However, considering that the batteries are not completely perfect and with the losses over time, it can be said that this minimum voltage will decrease even lower. For this reason, in order to eliminate future losses and problems, a minimum 30 volt, nominal 36 volt, and maximum 42 volt battery is obtained using 10 series Li-ions. Battery selection is necessary to calculate how many hours the battery pack can be used on average. The maximum current values of the batteries sold in market are well above the current values in this project. Considering the price-performance situation of these products, it is necessary to research and select the batteries with low discharge current and high milliampere hour capacity. According to quality, reliability, and capacity studies, LG branded Li-ion batteries was deemed suitable for this project. This is the calculations for hours 4 times. This is the battery we want to design together with the cooler. And that is our thermal analysis.
A battery management system must protect the battery from overcurrent, over-discharge current, overvoltage, undervoltage, and short circuit. Also, it must balance cells. There are 2 cell balance methods. First one is active cell balancing. In this method, allows the high voltage cell to charge the lower voltage cell. It can be used both charging and discharging period. This process is done with the help of the capacitor. A second method is passive cell balancing method. This method is done by discharging the energy of the cell higher state of the charge without a resistor. This method uses only discharge period. It shows the difference between the passive and active cell balancing method. This is a passive cell balancing algorithm. Firstly, it started with charge period. Then all cells voltages are controlled. If all cells are fully charged, then algorithm ends. If not, it is controlled. Is there any high charge cell? After that, high charge cell started to balance. The process continues until the cell maximum charge level and the cell with the minimum charge level are equalized. At the same time, if any cell becomes maximum charge level, it starts to balance, and it continues endless. We found IC called BQ76930 for cell balancing process. This IC not only eliminates the switching circuit elements for cell balancing, but also helps to read the voltage of the cell states. In addition, it provides protection such as undervolt, overvolt, higher discharge current, short circuit with external circuit elements, but it needs some microcontroller because it doesn't have EEPROM. These are requirements for coding the microcontroller according to the battery design. Our MATLAB simulation circuit is like this. BQ76930 IC can balance with maximum 5 milliampere currents. For this reason, we choose 1 kilo ohm resistor for balanced resistor to our calculation. However, MATLAB is balanced with 10 ohm because of the time, so the current must be reached 0.5 ampere in graphs. These are graphs. This is high charge level graph here. This is low charge cell graph. This is the current graph. As you can see, current reached the 0.4 ampere. This is our circuit. We designed to take reference from the datasheet of BQ76930.
This is our theoretical bill of material. We separate electric pipe into three parts: battery, frame, and motor. And this is our products and pieces, prices. This is our plans, plan A and plan B. In case of the anomaly of a plan A, we will switch plan B. And this is our future plan. Thank you for listening.